Bam! Mr. Taru. In this video, we are beginning our journey into Algebra 1. And these concepts you're going to learn are going to continue through Algebra 1, Geometry, Algebra 2, Trigonometry, Pre-Calculus, Calculus, Calculus 1, 2, and 3, differential equations. It basically goes through almost everything you're going to learn in mathematics from here on out. So these are very, very important days in your mathematical journey. And we're just going to start today by defining what a variable and what an expression is. We're going to ultimately be able to hopefully write some algebraic expressions after reading some word problems, if you will, some language. And if there's not enough examples in this video, because this is just an introductory lesson where we give you some vocabulary to go along with some of the examples that'll follow, I have another video that's going to be right after this one in my Algebra 1 playlist that I actually made about a year ago. Some problems may be a bit more advanced than what's in this video. You'd see it maybe the end of Algebra 1 or the beginning of Algebra 2. Okay, so at any rate, a mathematical quantity is anything that can be measured or counted. How many pounds you weigh, what's your GPA, how many miles it is from here to another city, or how fast I'm going. Just anything I feel like, measuring. And within those mathematical quantities, we have two types. We have a constant quantity, which would be something like the distance between two cities, or the number of days in a year, or maybe pi. Well, I can't put it in here because I got full sentences, but like pi, which is something that maybe you've learned by now, or you'll be introduced to it in geometry, which is the ratio of the distance around a circle, or the circumference, and the diameter. Those are constant quantities. They don't change. A variable quantity, this is what we're often most interested in when writing, algebraic expressions and equations ultimately for solving for word problems, finding out how many tickets we can afford to buy based on a set of money, or projecting how much maybe a phone bill would cost from a cell phone, something like that. And variables that change, or variable quantities, are like, say, population of a country. Your GPA is every time you take a class you get a new letter grade, and that changes your GPA. Shoe size of a child. Now, maybe as an adult I've been buying the same size shoe now for decades, but they do change when you're a kid growing up. Variable. A variable is a symbol, which is usually a letter, which represents a value. Now, when I begin my studies in algebra, a lot of times when I set up algebraic expressions from word problems, I like to just use full words, because a lot of times people think they never use algebra because we don't talk in X's and Y's. We talk about, well, I've got $20 in my pocket, a certain ride or a certain thing that I'm buying costs $3.75 a piece, how many can I buy? And, we can write that as an algebraic expression, but I would say, well, it's $3.75 times how many are you buying, and then it has to be less than $20. Well, in full words, that's an algebraic equation. So that can help the comprehension of setting up expressions and equations in algebra if we just use full words for these variables at the beginning, before we just drop in the X's and Y's or A's and B's or whatever. An algebraic expression is a mathematical phrase that includes one or more variable. Now, again, for it to be algebraic, there must be a variable. There must be some symbol that represents a number which we don't know. Okay? So it could be like x, it could be 2x, it could be 4x minus 2. This has one term because it's just x. This has two terms. Or excuse me, one term because it's 2 times x, whereas my last example here of 4x minus 2, this expression has two terms. They're separated by addition and subtraction signs. So the 4x is one term, and the 2 is your second. And by the way, the 4x and the 2x, this is called a factor. These are two factors, a factor of 2 and a factor of x. Factors are multiplied together and to create a term that we have here of 2x. Okay, oh, and you can have more than one variable too, like we could have 3xy. So you can have an algebraic expression that has more than just one variable in it. Numerical expressions, a math involving numbers and operation symbols, but no variables. Okay, so a numerical expression is kind of like what you've been studying maybe through elementary and middle school, and I know they start to incorporate algebra now in younger and younger grades, but like 2 plus 3, or just 5, or 2 times 3 plus 7. you know, I'm writing down phrases, but you know, there's no algebra involved. There's no variables involved. You know, 2 plus 3 is 5, or 3 plus 7 is 10, and then 10 times 2 is equal to 20. Now, I can say, like, you know, I can say that this equals 20, like I just verbalized, but once I write an equal sign, I'm kind of writing an equation. It seems kind of funny to say this is an equation with no variables to solve for, but an expression is a phrase that has no equal sign. Once you start writing equal signs, you're writing equations. I can evaluate this and say that this evaluated is equal to 20, but I'm going to avoid, just to not have any confusion, where we're not going to write any equal signs. That's going from writing a phrase into writing an equation, which is a huge part of algebra, is learning how to solve those equations and write equations to model real-world setups. Okay, we're going to run through some examples here. Because ultimately we do need to understand how to turn words into these algebraic expressions. So there's some catchwords in here for when you want to add, okay? I can say the sum of, so the word sum means that we're going to do some kind of addition, and it's the sum of. Now when you hear the word sum of, that's setting you up to tell you, okay, you're going to add two things, and we're about to tell you what those are. We're going to add the sum of 18 and. Now in algebra, when we give you an unknown, we generally say like a number or an unknown value. Or for just being really too simple, we could just say the sum of 18 and x. But, you know, that's really, really simple, and we don't often get that. So we have the sum of 18 and a number. Well, the answer for that is you recognize that the sum of means addition, and you write the rest of the equation, or excuse me, you write the expression in the same order that you see in your equation. So it's 18 and a sum, so 18 plus a number, so the correct answer is 18 plus x. Now this is an equivalent expression where it says x more than 18. Well, both of these phrases, to get full credit, would have to be written as 18 plus x. When you see more than, or the next example I'm going to put up on the board, less than, those two words together means that you need to switch the order of these items that you see in the equation. Okay? Now you might be going, well, why can't I write just 18 plus x? Because really that should be caught as being incorrect. The answer to both of these is 18 plus x, because more than, you must change the order. With addition, you don't maybe necessarily see why that order matters, like 5 plus 2 is 7 and 2 plus 5 is 7. So to explain why you need to change the order when you have this two-phrase expression of more than or less than, besides me just going, well, that's the way it is, let's go to subtraction to see why the order matters, and then that order just carries through that more than phrase. Of course I could just say, you know, I want you to write 18 plus x as an algebraic phrase or an algebraic expression. Just saying 18 plus x is too simple. You need to realize that the words of sum of and more than, these come up a lot in just plain language and in algebra, so we have to understand that those do mean, you know, addition. Next screen. The difference of a number and 17. Well, the difference. Now, the sum is add. Difference means that we're going to subtract. Okay, so it says the difference of. So that two-word phrase right there says, okay, we're setting up for subtraction, so subtraction. And what are we subtracting? Well, it's the difference of a number, a unknown value, which we're going to define as the letter x or a or b or d or whatever letter you feel like. There's only a couple that are taken up in the alphabet mathematically. Like E is approximately 2.718, but at any rate, the difference of a number and 17. So I want you to subtract two numbers, and in the order of the problem is x and 17. Well, if more than is adding to, then less than is to subtract. But again, it's that two-word phrase, more than, less than, means you must change the order that's in this problem. Okay, so let's say, okay, I'm about 62 inches tall, 6 feet tall. So if I'm 62 inches tall and you are 2 inches less than me, now I started to talk about your height first, you are 2 inches less than I am. Well, it's not 2 minus 62. You're not negative 60 inches tall. You're 62 minus 2 inches tall, or 60 inches tall. So, see, with subtraction, it really shows us why we need to take the order and change it in this word problem, if you will, or this phrase, and change that order, because, well, it doesn't make any sense to say that someone is negative 60 inches tall. It just doesn't make sense. So clearly we have to take that order and switch it. So even though 17 is first in the question, we need to recognize that less than means subtraction, like more than means addition. And remember, when it's less than, more than, we must change the order of the problem. So it is an unknown value of x minus 17. Okay, or I could just say x minus 17, or an unknown value minus 17. The product of 10 and an unknown value. Well, product is your algebra, your mathematical word for multiplication, which means that now that I'm talking about algebra and variables, writing an x is not a good thing because, well, is that a multiplication symbol or is that a multiplication symbol? But product does mean to multiply, and now we're going to be, again, with the math operation and immediately followed with of, we're going to be told now, what we're multiplying by, just like we were told here what we were subtracting. So we're going to multiply 10 and an unknown value. And that unknown value, another word of saying a number, is your unknown value. So we're going to do 10 times x, or you can write 10 times y, 10 times z, 10 times a. It's 10 times that variable, which is a letter representing an unknown value, an unknown number. The quotient of a number and 7. Well, a number, again, let's just pick another letter, A. Quotient means to divide, and there's that word of, where they're starting to set up, okay, well, we want you to divide. Okay, divide A by 7. So we can write A over 7, or we can write A divided by 7. So product is multiply, quotient is to divide, difference of or less than is subtraction, and sum or more than is addition. Let's look at some examples that have more than one math operation. We've got 4 less than. Okay, less than means that we're going to have to change the order of the problem, and less means subtraction. Okay, so the less than part is it's going to be 4 minus or taken away from something. 1/3. Well, to take 1/3 of something, like if you ate a third of the pizza, you would take that pizza and divide it by 3 equal sections, and that's how much you had. So taking a third of something is dividing it by 3 or multiplying it by 1 over 3. So it's 1/3 of. Now, a lot of times when of just sort of appears out of nowhere, not sum of, not difference of, or product of, or quotient of, if it just pops up alone, 1/3 of a number, then this standalone value of a lot of times, and you do need to read the problem and make sure that what you're doing makes sense for the context of the words that you're reading. But a lot of times when of just pops up by itself as a single word not followed by a math operation, it represents multiplication. So it's 1/3 of or times some unknown value, and I don't want to write x every time and make you think that the only variable we can use is x. So 1/3 an unknown value of b minus 4. The quotient, okay, quotient of, that's division, -2, so we're going to take, again, that math operation of, now we're going to come and tell you what you're going to now divide. Well, we're going to divide -2. That's supposed to be yellow to highlight the difference in the white. I hope you can see that. But we're going to divide -2 and the sum of. Oh, okay, so it's quotient, so we're dividing. I'm going to write my final answer as a fraction. And we're dividing by, or fraction bar means division, so that division sign is right there. And all of a sudden, oh, there's another math operation. Sum of. All right, so sum of following a math operation, so it's not multiplication. Okay, we're adding. Okay, well now we're being told that we're adding. Well, now I need to, stop and look. Okay, well, what are the two things that we're adding? Well, we're adding an unknown value, a number. So there's going to go back to my x, and I'm adding, because the word sum, x and 5. Okay, so it's 2 divided by, and you can write it like this as well, 2 divided by, and then because you're already trying to set up some math operation, as soon as you go into the addition, even though you're in the middle of trying to set up division, you want to use parentheses. And again, it's the sum of x and 5. Either one of those are equivalent statements. Now, I can even come over here and erase the parentheses around the x minus 5 because a fraction bar acts as a grouping symbol, which is like your parentheses. Okay, and all of the x minus 5 is under the fraction bar, and so that fraction bar is acting like a grouping symbol for the x plus 5. The sum of negative 7 and twice a number. Okay, well, math operation, word of together, sum of means addition, and what are you adding? Okay, well, we're adding negative 7, and so that's where that plus sign goes. So negative 7, sum of, so the plus, and twice a number. Well, twice a number is twice the quantity, and so it's twice some unknown value that we don't know, so let's just call it 2c, just to, again, use those different letters to represent these unknown values. We're going to look at another example here to begin the next board that involves some language that has 2 math operations in it, but it's not quite as clear what is the correct algebraic expression for that sentence. Bam! 3 less than 7 divided by a number. Okay, well, this is the one I said would have some, how can we set it up the best? Well, it's, okay, well, I keep using the less than and more than phrases because I want to remind you, got to flip those sentences around. So it's 3 less than, but again, that 2-word phrase, you got to change the order. So it's 3 less than taken away from 7 divided by a number. Pretty simply worded, just take 7 divided by a number. Or is it 3 less than 7 divided by an unknown value? See, the way it's worded leaves a little bit of ambiguity, a little bit of unclarity to it. It's unclear, which of these two are truly correct. So that's why I've taken the sentence and reworded it a little bit into 3, again, less than. Switch those orders. And now, that's why this is such a nice clean expression where it's a math operation and then of. Okay, I want you to take the quotient of, and I want you to take the quotient of these two things. And the quotient, of course, means divide. So it's 3 less than the quotient of 7 divided by a number. So it's 7 divided by a number. That quotient less than, or 3 less than that quotient, or I'd rather write this as 7 over x minus 3, and the way this is worded leaves no question as to how you need to write the final answer. Write a word or phrase of these two. Now, since I just got done talking about how this quotient of, sum of, difference of, that math operation, the word of, so clearly defines how we need to, what order we need to do the problem in, or where the parentheses need to go, if you will. What do we have here? Something better than just 5 minus x. That's too simple. Your word problems, and sometimes we have, again, these word problems that are not that clearly labeled. So we could write, let's see, what do you think? How about x less than 5? Okay, well, that's not the only answer. You could write what other word was for subtraction? How about difference? The difference of 5 and x. So if I'm going to write the word difference, the 5 has to come first. The difference of 5 and x, or x less than 5. Now, what about the bottom one? How about just 8 less than, and to make sure that we understand that that 4x is clearly together, how about 8 less than the product of 4 and an unknown value, And actually probably up here would be better if I said like a value or a number or an unknown value less than 5, or the difference of 5 and an unknown value. Not even use the letter, say the letter X in our final answer. So those are some good phrases. Let me pause it and get that written up here before we do an application problem, a word problem. A repairman charges $70 service fee for them to just come out to your house and or home or apartment or whatever, and $50 an hour for a repair if one needs to be made. If a job takes H hours to write, now this is where I say, like in word problems, no one says, oh, well, the bill is, you know, blah, blah, blah times H. It's just like, well, I charged so much to get here, and I charged $50 an hour. You know, plain words. But at any rate, we have the letter H for hours. Write an expression for the total cost. Okay, well, when you write an algebraic expression, or equation for that matter, I could write cost equals, and then boom, I'm writing an equation instead of an expression. The number that repeats is going to be the number that has the unknown value, the variable, because in here the quantity that we're measuring is the number of hours the serviceman takes to do the job. Now, if you're not sure of how to do the problem, let's not forget that a variable is a number that you just don't happen to know. So whatever you do with actual numbers you can come up with in your head, well, then that's going to be the pattern to set up how to set up the equation, or to help you set up the equation. So let's just say, if I don't know how to do the answer, right? Okay, so let's just say that the number of hours it takes to do the job. Well, let's just say it's 0. The dude comes out, or the lady comes out, she goes, oh, well, your circuit breaker just blew, I just reset it, and there's nothing to fix. But I had to come out here, gas and insurance, all that good stuff. So you're going to get paid, or charged $70, or you're going to pay $70. So the cost is 70. Well, what if they took 1 hour to do the job? Well, it was 70 to come out, and the 50 that they charged you for that 1 hour of work. What if it was 2 hours? Okay, well, if it was 2 hours, they charged you the 70 to come out. They charged you the 50 for the first hour. They charged you the 50 for the second hour, and you ended up paying $100 and $170. What if they came out and it took them 3 hours to do the job? You see, like, what I'm doing is I'm allowing your brain, or I'm trying to give you the hint that you've been working with numbers basically your whole life. You've been learning math. Whereas in algebra, all of a sudden we start introducing these variables, these unknown values, and that gets people all confused. But the pattern I'm doing here is going to be what you will do with the variables, the unknown quantities that we're working with, the hours or the H. So again, 3 hours, it's 70 to come out. First hour, second hour, third hour. I was going to write 3 for what I was saying 3 hours. Do you notice how every time I write how long the repairman is there, that's how many times I write 50? Whenever I'm tutoring students and they don't know how to set up an equation, I go, well, what if they were there for 3 hours? Inevitably, I'm going to get the right answer. Okay, well, what did you do? Well, there was there for 3 hours, so I added 50 3 times. Well, multiplication represents repeated addition, so you really did 70 plus 3 times 50, or you did 70 plus 2 times 50, or 70 times 1 times 50, or 70 times, excuse me, I keep saying times, add, 70 plus 2 times 50, or 3 times 50, or 70 plus 2 times 50, or 70 plus 1 times 50, or 70 plus 0 times 50. The pattern is this number of hours is how many times we write that addition of 50, or how many times we multiply by 50. So our final answer is, and I'm sorry if that was so slow, for those of you that got it right away, it is 70 plus 50, and if I had more room I would write times number of hours to complete the job. And then, you know, plain language people understand and use every day, and then shorten it up to just 70 plus 50H. I got 3 more examples or application examples and we're done. So you and some friends are going to the movies. If the tickets are $8.50 a piece, write an algebraic expression for the cost. Well, if it's just you, it's $8.50. If it's you and a friend, it's each of you paying $8.50 or $8.50 plus $8.50. Got 3 friends? Well, if you have 3 friends, I guess that's 4 people, so it's going to be $8.50 times 4. So if you can figure it out for 1, 2, and 3, and 4 people, then you can figure it out with algebra. It's just $8.50 times the number of people. I mean, that's how people talk. But us algebra people, us math teacher, be like, you need like a symbol to represent a variable, so like that doesn't work. Even though people talk like that, it's going to be $8.50 times x or times p for people, which would probably make the most sense. But it's $8.50 times an unknown value. You are paid a weekly salary of $270. That looks like a comma, period. And you earn a 2% commission on your sales. So you make a flat fee, or not a fee, a flat income of $270 a week. If you don't sell a single item, maybe you're selling cell phones or something at an electronics store that, you know, pays commission. You're going to make $270 a week if you just stand around, you know, picking your nose, right? But on top of that, you're going to earn an extra commission, an extra income, if you will, on what you're going to make for that week. Well, we generally, unless you're doing like part over whole equals x over 100, which is sort of like a way of setting up a lot of, with cross multiplication, problems that deal with percents. If you're writing an algebraic phrase or an equation other than that special cross multiplication setting, you never really work with percents as a percent. The vast majority of the time, basically we'll just say all of the time, when you work with percents, you want to turn that percent into a decimal. So we're going to take the 2% and we're going to take that decimal that's at the end of the 2 and move it to the left 2 places and say that the 2% as a decimal is 0.02. Okay, well now how do I figure out 2% of your commissions, your sales? Well, I don't want to give away the answer. If you've ever bought anything at the store, you pay tax. Like where I live, sales tax is 7%. That means 7%, move it back 2 places, 0.07. Oh, well, 0.07 in terms of money is 7 cents. So every $1 I spend, I'm having to also pay an additional 7 cents on every dollar I buy, that I spend to buy something. So that's the sales tax. So if I buy $1 of something, I pay $1 plus 7 cents. If I pay $2, it's $2. Okay, well it was 7 cents for the first dollar, 7 cents for the second dollar. So that's sounds like 2 times 0.07. If I spend $3, then that's 7 cents on every single dollar. And if I keep adding 7 cents, that sounds like multiplication. So to find a percent of something, you like your 2% of your commission, it's going to be multiplication. So your salary every week is going to be the $270 you get for just showing up for work. Of course, if you never sell anything, you probably get fired. But you get that plus your 2% times the amount of sales. Which, again, generally in a math book, you're going to see that as 270 plus 0.02 and then some, maybe capital S to represent some letter to represent your sales. Our last example, I'm not sure if this necessarily be in your textbook or not, but my kids are going to deal with it, is we have these blocks. It's a pattern. We have 3 blocks here, we've got 5 blocks here, and we have 7 blocks there, and ... indicating it goes on forever, if you will. And looks like I'm adding by what? 3, 5, 7. Okay, so I'm adding by 2, which, by the way, later on in mathematics, You're going to learn that this is your introduction to something called an arithmetic sequence or series. So we're adding by 2. All right, so to get from this grouping which I've labeled as an n value of 1, just a numerical value representing that first picture, we're going to add, and make my ears scream, we're going to add by 2, sorry about that. Then to get from 5 to 7, we're going to add by 2. So our initial value is 3. This first picture in our pattern has 3 blocks in it. And then from there, to get to the next, to get to the next, to get to the next picture, I'm adding 2 blocks. Okay, well, how many times am I adding by? Because I want to write this expression in terms of this variable n. Well, and I'm repeatedly adding by 2, which is a notation for, or we can rewrite that as multiplication. So when n is 2, to get to the second grouping, I've added by 2 only once. So n is 2, but I've added by 2 only once. Then we get to the 1, 2, third grouping, the third picture, and when n is 3 based on that label, I've only added by 2 twice. So when n is 2, I've only added once. When n is 3, I, from the beginning, had to add twice. So when I get to the fourth group, to get from the beginning, I would have to add 1, 2, 3. So it seems like whatever n is, I'm adding by 2, 1 less than that. Now I'm not really sure if that's right, so let's check it. What does this expression equal when n is 0? Well, it's 3 plus 2 times, excuse me, I don't want to have n equal 0 because I started my n out value at 1. So what happens if n is equal to 1? Well, it's 3 plus 2 times 1 from here, or from the first picture, minus 1. Well, that's 3 plus 2 times 0. Well, 2 times 0 is 0, and 0 plus 3 is 3. Well, what if n is equal to 2? Well, 3 plus 2 times n is 2, 2 minus 1, that's 3 plus 2 times 2 minus 1 is 1, and 2 times 1 is 2, and 3 plus 2 is equal to 5. So it seems to be checking out. One more time. If n is equal to 3, then 3 plus 2 times 3 minus 1 is 3 plus 2 times 3 minus 1 is 2. Well, 2 plus 2 is 4, and 4 plus 3 is 7. And that's how many blocks we have in our third picture, and that pattern is going to continue. So this algebraic phrase is describing the number of blocks in each of these pictures labeled first, second, third picture, and so on. And we've got a phrase to represent that pattern. So that's a lot of examples. That's your introduction to setting up algebraic phrases from word problems. I'm Mr. Tarrou. Bam! Go do your homework.